Right, grade 11s, let's continue with this. Grade 12s, you need to be listening as well. Let's have a look at another thing. We had a parabola that was happy, and we had some x-intercepts, -1 and 1, and now we're asking some questions. For which values of x will the parabola lie below the x-axis? Now watch this. Remember, we're not asking for where it's cutting. Now watch this. There's your happy parabola. There's its 2 x-intercepts. We'll work that out as we go along. Now this was given as an example. Now if you look at it, we're not cutting. They're not asking for which values of x will the parabola cut the x-axis and lie below it, so we exclude those values. We don't want where they cut. But where is the parabola below? Look at it, it's below there. Can you see there? It's below from there to there. Okay, now how we write this is so important. For below, what I do is I'm going to put a little imaginary x here. Now I want you to watch this. I'm going to put a little imaginary x here. Okay, now have a look at this. If I put an x there, okay, those are numbers between. Now those are the x's. For which values of x will the parabola lie below? So if you go from -1 to 1, you below. Now how do we express that then? Okay, now look at this. I say from -1 is less than all those other numbers there. It's less than x, and all the numbers, the blue numbers here, are less than 1. So it's always going to be in this form, your inequality. If it's less than, we keep it less and less. Okay, between, it's below. Okay, so hold on to that. Okay, let's look at number E now. For which values of x will the parabola lie below or cut? Okay, that means that we less than 0, and we can include where they cut. Now look at this, there's your values. So we are definitely below or cuts. We're cutting, so we can include those. It's a closed dot. As we develop this, you're going to see it, below or cuts, and we are below from there to there. Now remember, when you're below and you've got between these two, we start off with -1, we end with 1, we include them, we have equal signs here because we want where it cuts, and we want where it's less than and equals. If ever there's an equals there, the inequality sign itself keeps the same direction. Except when you're above, that's different. Then we go the other way. That's important. So we're below. So this is so important when we're below. Okay, now what I want to do is explore some examples of inequalities. Now stay with us. In this lesson and the next one, we're going to explore some ideas. Now watch this example 1. You've got to solve for this. X squared is less than 9. That looks like a parabola. If I bring the 9 across, I get a parabola. Now, x squared minus 9, the number, look at this, the number next to x squared is a positive. We always want it to positive. It's a happy parabola. And that x squared minus 9, we're going to get the x-intercepts. We factorize it as a difference of 2 squares, x plus 3, x minus 3. Okay, and what we do is we're going to now explore the x-intercepts of the parabola. Now notice also the inequality sign is less than or equal. That means below or cutting. Okay, now if we take that less than or equal means below for the less than 0, underneath less than 0, and the equal says cut. Okay, so now hold on to this. Now what we do is we draw a little parabola. So we know that we've got our -3 and 3. Where did I get that from? Well, what I did is I put these equal to 0. I put them equal to 0. So very simply, x plus 3 equals 0. You put it equal to 0. Let me just write that quickly. You go x plus 3 is equal to 0. So x is minus 3. Or you can say x minus 3 is 0. X is equal to 3. And you get your x-intercepts there. And it's always got to be a happy parabola. The x squared's always got to be positive. Now, we want to know where it's below or cuts. Well, that's where it's below, from -3 to 3. And if it cuts, we can include those values there. Now, it's one of these guys that is in between. So we start at -3, we end at 3, we have equals like the original, and you always use it. It's less than, and the less thans follow. We in between there. And there's your answer. Okay, so follow. We're going to do a lot of these to make sure you understand it. Okay, right. Example 2, guys. Let's look at this one. Oh, this is really nice. If we take this, I'm going to most importantly bring the x and the 6 to the left. Listen, you've got to have greater than 0. You've got to have a naught on the right, because listen, what does greater than naught tell us? Bigger than naught is above. Wah, wah, like that bird flying, okay. All right, and then you've got below is less than naught is below, okay. And what we do is we've got that, so it's very important to bring everything to the left. The parabola is happy, okay, and what we can do is we factorize, okay, above x-axis there, and we then can represent this. Now here we go. Now how do we get the x-intercepts quickly? I'm just going to change from our previous ones. If you go x minus 3 is 0, then x is 3. Now 3, instead of having 1 now, we've got different ones. We're going to use a 3 there now. And x is minus 2. We're not going to use that one. We're going to use a minus 2. Okay, so let's see what happens now. Okay, well, if we're going above, okay, we're not cutting, so we put closed dots, open dots. Above is to the left, and it's to the left of minus 2, and above would be to the right of 3. And then we summarize it. Now look at that. That word "or" is important. You've got the two wings of the bird, okay, and it's going, the bird's flapping and saying, awesome, awesome. Okay, you got it, because that's why we use the word "or." Awesome. Okay, now to the left there, and also watch this, guys, quickly. If you have a look here, notice that you're going to the left and to the right. Those are the inequalities, they follow. See that? To the right and to the left. And don't forget the awesome. Now, stay with us, guys. We're going to do some more of this in the next lesson on Matrics Uploaded.